Hey everyone, welcome to Echoes of Reality. Today we're exploring something you do every day, but probably don't fully understand. Sleep. Right now, as you watch this, billions of people worldwide are fast asleep. Billions of humans, all unconscious, doing this mysterious thing called sleeping. Sleep 8 hours nightly? You'll spend a third of your life asleep. I've already slept away over 10 years, and that 1/3 directly affects the other 2/3 of your life. Sleep is fundamental to human life. Poor sleep ruins your mood, health, and relationships. But here is the real question. Why do we need to sleep at all? Spending a third of our lives unconscious seems wasteful, right? Couldn't we be more productive? This question leads us somewhere deeper. What is sleep actually for? To understand sleep, we first need to define it. And surprisingly, there is no universally agreed upon definition of what sleep actually is. Long ago, people thought sleep was simply losing consciousness for a period of time. But that is not quite right. You can wake someone up so they haven't truly lost consciousness. True unconsciousness means you can't be awakened no matter what. That is not sleep. That is a coma. Sleep is something different, something more mysterious. Here is something strange. Most people can't pinpoint the exact moment they fall asleep. You're lying in bed, awake, and then suddenly you're waking up hours later. You don't remember falling asleep. No one around you can tell exactly when it happened either. There is no clear signal, no obvious change, just a mysterious transition. Some people snore, so you know they're asleep, but most don't give any obvious signs. Sleep remains one of the most enigmatic transitions we experience daily. Modern science defines sleep as a state where your sensory and motor activities temporarily pause, but can be quickly awakened with appropriate stimulation. Wikipedia describes it in more complex terms. The brain temporarily shifts excitement to different neural cells, blocking external stimuli to process and consolidate information. Simply put, living beings periodically enter a state where their senses respond poorly to external stimuli, almost as if consciousness has faded away. Give them a strong enough stimulus, and they'll snap back to full wakefulness immediately. That is the key difference between sleep and unconsciousness. Different people need different levels of stimulation to wake up. Some sleep through loud TV shows, while others wake at the slightest sound. The key principle is this: true sleep must include the ability to be awakened. If you can't be woken up, you're not sleeping, you're in a coma. Sometimes when people are exhausted or intoxicated, they look like they're sleeping but can't be roused. That is not sleep. That is a state of unconsciousness or coma. So there is actually a period during intoxication where it is partly coma and partly sleep. If you can wake them, it is sleep. If you can't, it is coma. Now that you understand what sleep is, ask yourself, are you actually sleeping each night? Or are you experiencing something closer to unconsciousness? Do humans really need to sleep every single day? The answer might surprise you, not necessarily. Some people can go 2 or 3 days without sleep. When I was younger and working intensely, I genuinely went 2 to 3 days without any sleep. And there is even a world record, 11 days without sleep. That is the longest verified record of human wakefulness under observation. So clearly, we don't absolutely need to sleep every single day to survive. That doesn't mean humans can go without sleep forever. We can skip days, but eventually sleep becomes unavoidable. The question is, why? Most people think of sleep as rest for tired bodies. You're exhausted, so you sleep. But what if you did nothing all day? You'd still want to sleep. Hospital patients lying in bed all day still sleep on schedule. They're not physically tired, yet they still need sleep. so sleep isn't really about physical rest. To understand why we sleep, we need to look beyond humans. Let's explore how other creatures in nature handle sleep, or don't. First important fact, not all living things need sleep. Plants and fungi, for example, don't sleep at all. They only exist in states of living or dead. Some plants close their leaves at night and open them at sunrise. But that is not sleep. You can't wake them up. It is just a mechanical response to light. Plants and fungi only have concepts of life and death, not sleep and wakefulness. Their other states aren't obvious enough to distinguish. Even among animals, not all need sleep. Only creatures with advanced nervous systems seem to require it. Simple organisms never sleep. Creatures like tardigrades and flatworms have extremely simple nervous systems. They're constantly active. You'll never catch them sleeping. This reveals something crucial. Is sleep for the body or for the mind? If only advanced creatures sleep, it seems sleep is primarily for the brain, not the body. Think about it. Simple creatures have bodies too. Don't their bodies need rest? Apparently not. You can rest your body while awake. Sleep is about something else. Among higher animals, sleep patterns vary dramatically. Herbivores sleep much less than carnivores. The giraffe holds the record for shortest sleep time. Giraffes sleep only about 20 minutes per day. And of those 20 minutes, only 5 are deep sleep. The rest is barely distinguishable from being awake. Cows, sheep, horses, and elephants sleep only 2 to 3 hours daily. And they don't sleep continuously. It is broken into 20 to 30-minute segments throughout the day. Why do herbivores sleep so little? First, their food is low in nutrients and energy. They must constantly eat to maintain their large bodies. Second, they must remain constantly alert for predators. To survive, herbivores can't afford long periods of vulnerability. Less sleep means better survival odds. From an evolutionary perspective, herbivores that slept too much simply got eaten. The survivors are those genetically programmed to sleep less. Now let's look at carnivores. Tigers and lions sleep 10 to 20 hours daily. Wild carnivores spend most of their time sleeping, not hunting. Why do carnivores sleep so much? Their food is high in energy and nutrients. One good meal can sustain them for days. No need to constantly eat. Plus, carnivores face little threat from other animals. They're apex predators. They can afford to sleep deeply without constant vigilance. But here is the puzzle. They can afford to sleep longer, but why do they need to? Why not use that time for something else? This reveals something profound about sleep's true purpose: conserving energy. When there is nothing important to do, sleep is the most efficient way to pass time. If carnivores stayed awake, they'd burn through their food reserves too quickly. They'd need to hunt constantly. Sleep solves this problem elegantly. Plus, staying awake means moving around, which increases injury risk. For predators, sleep offers benefits with virtually no downsides. It is the smart survival strategy. Now let's consider humans. We're safe from predators. Our food is even more nutritious than what lions eat. So why don't we sleep 20 hours like they do? The answer lies in human desire and ambition. Unlike lions, we have goals, dreams, and things we want to accomplish. We want to stay awake. Lions and tigers have no desires beyond eating and reproducing. When those needs are met, they have nothing else to do. Sleep fills the void. Humans are different. We have rich mental lives. Our advanced nervous systems created something unexpected: a need for constant mental stimulation. Here is a fascinating thought. Human consciousness is almost like a bug in our system. We constantly need to process information, or we feel distressed. Our mental system feeds on information, the way our body feeds on food. Without information, we experience something like mental hunger, and it is painful. If information we receive is high quality and engaging, we feel satisfied quickly. If it is boring or meaningless, we get drowsy fast. For humans, body and mind are genuinely separate systems. The body feeds on food for growth. The mind feeds on information for fulfillment. When we can't access useful or needed information, what happens? We get sleepy. It is the brain's energy-saving response to information scarcity. Attending a boring meeting where you understand nothing, you'll get drowsy. Watching an uninteresting movie, same thing. Studying material you don't need, instant sleepiness. Why? Your brain determines this information isn't valuable. To save energy, it triggers sleepiness, just like lions conserving energy between hunts. Sleep functions like a computer's hibernation mode. When there is nothing to process, the system enters low-power mode to conserve resources until needed again. From this perspective, humans are remarkably similar to robots. We have internal batteries, or fat stores, that let us operate without constant external power. Our battery allows wireless operation. Our job is collecting information. When night falls and light dims, information gathering becomes difficult, so we hibernate. Some people love going out at night to gather information. This raises an intriguing possibility. What if we're alien probes sent to Earth? Maybe we were sent here to collect data. To keep functioning, we must constantly consume food. Our purpose: gather information about this planet. The ultimate goal: build technology capable of reaching other planets and continuing exploration. We're self-replicating exploration machines. And the system that sent us here was brilliant. They didn't send humans initially. They sent a single cell, a seed of life. That cell divided and evolved into plants and animals. Plants stay still, converting inorganic matter, light, and water into energy for the system. Herbivores eat plants, concentrating that energy further. Carnivores eat herbivores, concentrating it even more. Energy becomes increasingly dense up the food chain. Humans eat both plants and animals, achieving maximum energy concentration. We then use this energy to build technology capable of space travel. It is a perfect system, converting rocks, water, wind, and sand inorganic matter into spacecraft capable of reaching other worlds. Almost too perfect to be accidental. You're telling me this happened naturally. The elegant precision of this system makes me wonder if there is intelligent design behind it all. If sleep's purpose is just passing time and conserving energy, not repairing the body or mind, then theoretically, we could sleep just 1 or 2 hours daily. Some Japanese TV shows featured people who sleep only 45 minutes nightly and remain perfectly functional. They claim humans don't need much sleep. I think this varies by individual. Some people need more sleep, others less. It might be genetic. Everyone's internal system has different requirements. Personally, I don't need that much sleep. If I sleep less, the next day I don't show many symptoms. But others really suffer without adequate rest. The real problem with modern sleep is society's demand for synchronization. We force everyone onto the same schedule, which disrupts natural biological rhythms. You might naturally sleep best from 11 p.m. to 5 a.m., but work and social obligations force you to adjust. This creates conflict with your internal clock. If you live with others, you can't have everyone sleeping at different times. Social coordination requires synchronized sleep schedules, even if it is not biologically optimal. For example, school starts at 6:30 a.m. You must be in the classroom, But what if your body naturally wants to sleep until noon? So the whole family must wake at 5:30, all because society demands this synchronization. The pressure of coordinated schedules creates sleep problems for many people. Think about it. Isn't it insane that school starts at 6:30 a.m.? The purpose is simply to train you to be a machine, to enforce conformity. Looking back, it really is absurd. 6:30 a.m., going to school in darkness, returning home in darkness, like wearing stars and moon as clothes. Goal is conformity and synchronization, nothing more. And we accept it without question. That is the system training us to be compliant machines. Now let's talk about babies. Newborns sleep about 18 hours daily. Why? Because they're bored. They can't move, can't understand anything around them. All they see is the ceiling, or maybe an old person shaking a rattle at them. They don't recognize anyone. It is incredibly boring, so they just sleep. As cognition increases and age advances, sleep needs decrease. The more there is to learn and experience, the less we want to sleep. Research shows human sleep consists of two alternating states: rapid eye movement, sleep, REM and non-REM sleep. During REM, your eyes move rapidly beneath closed lids. You dream during both REM and non-REM sleep. These states alternate in roughly 90-minute cycles throughout the night. If you wake during REM sleep, you'll usually remember your dreams clearly. Wake during non-REM, and dreams are mostly forgotten. This shows the brain remains very active during sleep. You've probably heard that the brain organizes the day's information during sleep. Study, then immediately sleep, and you'll remember better, right? Actually, that is not quite accurate. Recent research reveals the brain does organize memories during sleep, but it is selective remembering some things while discarding others. What does the brain keep? Information related to survival. Specifically, two types: physical memory and emotional memory. Physical memory includes learning guitar, riding bikes, swimming. During sleep, the brain rehearses these movements repeatedly, strengthening the neural pathways. That is why you can practice guitar poorly, sleep, then wake up suddenly playing better. Your brain processed and perfected those movements while you slept. Why is physical memory so important? Because these are survival skills. The brain prioritizes anything your body physically experiences as potentially crucial for survival. The second type is emotional memory: joy, anger, sorrow, fear. These emotions are also critical for survival, so they're reinforced during sleep. If you experience terrible fear somewhere, that memory must be preserved. It warns you to avoid that place or situation in the future. Similarly, happy experiences are remembered, so your brain can motivate you to seek them again. Emotions guide survival behavior, so they're deeply encoded. But emotional memory reinforcement creates a problem. If you experience something traumatic, like heartbreak, and immediately sleep, you're in trouble. Sleep won't heal psychological wounds. If you sleep right after trauma, that pain becomes deeply embedded. You must let emotional pain fade before sleeping. In sports, if an athlete gets injured during training, they shouldn't sleep that night. Wait until the pain and fear subside, or they may develop lasting psychological barriers to their sport.